观众朋友们好，感谢大家来到本阶段的思想先驱报节目现场。近期啊，这个何民先生啊，感觉是年轻了20岁啊，每天啊是穿着一身小粉衣服啊，来到了办公室，每天春光荡漾啊，在他的办公桌前啊，是时常传来银儿般悦耳的笑声。为什么呢？就是何民先生近期啊是认识到了 AI 的魅力啊，因此呢，每天学习 AI 技术是不亦乐乎。那我就要问何民先生一个问题啊，如果把中国和美国的 AI 技术啊相比，我们进行一个我们叫做这个拳头对拳头的比较，你认为美国领先中国多少？中国和美国之间的差距到底多大？是不是中国的所有技术都只是美国的拷贝品，还是说中国在 AI 技术上也有一些独门绝技？
这就像中美关系一样的啊。那么中国呢，希望建立一个新时代的中美关系啊，甚至有人提出来全世界是2个国家的来共治。我就觉得这种想法还是比较天真的，但是美国提出的是呢这个竞争关系，我也觉得不太恰当。为什么呢？因为谁比谁厉害，这个事情是看你的量化标准，那个标准是不是一致，你量化的标的物是不是一致。如果你各自的长处不一样，就很难说谁比谁厉害。其实中美之间的很多的长处啊，是彼此不具有取代的这个可能性啊。你像美国的这样一个，美国就是全世界最独一无二的一个国家，你不要认为它是可以复制的国家。美国的这一套还没有在任何一个国家复制成功过，是因为这个国家的形态，这一开始就决定是这样。大家只看到了5月花的这样一个船上的这么一个他们的契约啊，成为美国的民主的基础。你没有想到原来这里是一片这个原始生态一样的东西啊，原住民在那么一点情况之下就莫名其妙死了，病毒和战争就轻易就死掉了，而且可以一个英国的小商人可以运一点乱七八糟的东西到非洲去，然后就运了一批海螺过来啊。那美国的这种组合方式全世界是没有的，而没有的话造成耗了他国家的强大很多优势，其他国家很难竞争超过。所以中国用简单的超过美国这个命题就开始是错的。那反过来讲，美国要去打击中国一些美国的短处，美国也未必是成功的。所以我觉得从这个意义来讲这个人工智能很难说谁会超过谁，而是说各有所长。
刚才何明先生提到一个关键，叫做各有所长。其实这也正好是专家的观点。那么在上周我很有幸这个为亚洲学会这个政策分析中心的中国研究中心主持了一档节目，主要就是分析刚才我们讲到的这个话题：中国和美国在 AI 技术上的竞争，以及美国到底能不能够把中国的 AI 发展以政策手段或者以其他的手段挡在之后那么当时呢，这有一位专家他呢曾经是美国政府的一位官员那么对于中国科技非常有了解，叫做 Paul Triolo
也很有意思。中国的官员一下台就变得很大胆，美国的官员一下台就变得很聪明。
是有可能反正不知道这个 Triolo 先生在台上的时候他怎么样我们不知道他是不是笨，但是下台了之后的确是提供了很多给我们的真知灼见他现在呢是 CSIS 专门负责跟科技以及中国经济相关的一位高级研究员那么他就跟我讲说，实际上在2017年的时候，他和李开复有这样的一个合作的研究，他们研究的话题就是刚才我们谈到了中国和美国在 AI 各个领域实力到底如何。专家当然是进行了非常严肃的分析，但我们今天先把研究的主要结论分享给大家。中国在 AI 的哪一些方面可以说是领先或者有独到之处呢？首先，比如说叫做 AI 成像和 AI 识别，那么有一些领域可能大家并不惊讶，比如说在这个大规模监控、人脸识别这一方面，中国是非常的厉害。而同时呢，在医疗方面，那比如说用 AI 来判断肿瘤，用 AI 来进行诊疗这一方面，中国呢实际上在科学上一直走在前沿，并且和美国有非常好的合作。还有我们也不惊讶，就是自动驾驶Triolo 先生特别说，他之前几个月到了北京去，还专门有这样一个机会在北京坐上了小马智行的人工智能这样的一个计算自动驾驶车。他就说说比我开的这个 特斯拉好多了，说小马智行的这个整个全自动驾驶啊，现在已经是到了第4代，而这个特斯拉呢，基本还是在第2代或者是第2代半这样的一个水平。所以呢，全自动驾驶也是中国 AI 的一个我们叫做独门绝技啊，或者是说发展的非常好的一方面。那么美国和中国在哪个环节相比，美国是占有绝对的优势呢？他提了2方面，首先是硬件方面的硬件，比如说芯片啊，这一方面中国还没有办法和世界前沿水平比较，等一下我们再详细讲。还有第2个方面就是软件，现在进行人工智能开发以及模型运算的绝大多数的我们叫做编程软体啊，不管是 PyTorch 也好，还是 TensorFlow 也好，TensorFlow 也好，基本上都是美国开发的。那么中国在人工智能软件开发上和美国还有相当大的差距，所以整体来讲，如刚才何明先生所言，各有所长，很难说谁就比谁占了先机。那我们的这个讨论呢，进行到后半环节啊，我们就讨论到另外一个我们非常关注到的问题，就是美国与中国之间的芯片竞争。美国对于中国采取了比如说出口管制啊、制裁啊等一系列措施，但是我们看到似乎效果是比较有限的。之前我们提到华为的 Mate 60手机让美国决策者大吃一惊，赶快回来找自己的出口管制漏洞到底到哪里。那到底是出口管制之前多了漏洞，是华为以偷抢蒙骗的方式从世界其他地方获得了它不应该获得的技术，还是哪一些其他的原因？而在谈到这样的一个话题的时候啊，Triolo先生也与我分享了在我看来非常有益的一些见解。首先呢，他又讲到了一个问题，就是说美国政府对于华为的警惕和怀疑，其实并不是最近1-2年才开始的，10几年以来，美国就一直阻止国内的电信公司使用华为的设备。但是呢，在2019年，美国的商务部把华为列入实体清单，可以说对于华为的打击是非常之大的。但是当时呢，美国的这个理由啊，也让大家觉得是找了一个理由。那我们还记得，华为当时上了实体清单的名义理由是涉嫌违反了对于伊朗的制裁。其实这个案件已经有10几年了。就是这个美国政府是抓住这样的一个契机，在认为华为的技术对于自己构成威胁的时候，出台了对于华为的商业禁令。那我们知道，随后针对华为啊是有一系列的管制措施，而最厉害的是2020年新增的，可以说是完全把台积电的供应从华为切断，导致华为全球消费手机的业务基本上是处于一个半夭折这样的一个状态。那我们知道，智能手机啊，它不仅仅是一个硬件，它需要最先进的半导体，以确保性能可以稳步提升，能耗可以有保障。这样呢，消费者可以不断的在智能手机上使用最新的服务，运算速度不断升级，等等等等。现在在整个世界范围内啊，先进的前沿芯片在智能手机上部署，比如说3纳米、5纳米等等等等。那么这个3纳米、5纳米是什么概念呢？我们之前介绍过，是衡量芯片上晶体密度的一个标准，数量越少，性能就越高啊。这个晶体管排列的越紧密。在2022年的时候，去年的10月份，美国是再次收紧了对于中国的出口管制限制，不仅仅是限制住了芯片，对于工具和机器也增加了更多的许可证，并且增加了最终用途控制。但是Triolo先生又提出了一个观点，说其实出口管制这样一种政策这样的一种手段，根本就不是为了控制科技产品流向而定的。本来出口管制历史上主要是冷战期间、核战期间针对军事应用或者是大规模杀伤性武器所进行的这样的一个法律的设计。那我们知道，大规模杀伤性武器或者是核武器，其中有一些内部组件和原料它是非常清楚的。但是到了新科技，有一个什么样的问题？新科技的这一些组成元件、这一些基本技术，它本身就是一种市场化的技术，它本身的终端用途是不确定的。任何一种技术既有军用用途，也有民用用途，既有消费产品的用途，也有军事产品的用途，所以你很难最终确定你拦住的到底是哪一些技术和产品。同时呢，Triolo先生又提出了另外一点，就是美国对于中国进行出口管制到底要达成什么目标，这一点始终是不明确的。Triolo先生说，他自己叫做沙利文主义这指的是2022年10月，去年10月的时候，美国国安顾问沙利文强调的是，美国要保持在技术领域的绝对优势而不是相对优势，要甩开中国技术发展1个世代甚至更多，这呢是一种说法。 但是同时呢，美国对于中国进行出口管制时候所援引的直接法条，又是为了限制中国军事应用的发展。那么到底你是为了防止跟军事有关的技术留给中国，还是为了要把中国的科技发展抬在自己身后呢？这就导致了美国政府内部现在对于中国出口管制一个理论上或者叫做名义上的这样的一个不确定啊。那我就想问一下何明先生，Trello先生提出了几点：第一，针对大规模杀伤性武器、针对核武器的这种出口管制，已经根本没有办法解决现在新兴技术这样的一种全球性所导致的这样的一种渗透性的问题。也就是说，你用错误的工具来解决问题本身。第二就是，就连解决问题本身，你也没有明确定义，到底是解决什么样的问题？到底是希望和中国展开科技竞争，还是为了防止中国获得尖端武器的力量？第三呢，就是即使是单看华为这一家公司，美国对于华为的限制也很难说名正言顺，因为你实际上是举了一个很陈旧的案子，10年多就有的对于伊朗的制裁，而对于这样一家中国企业进行相应的惩罚，似乎很难以理服人。那你觉得他说的这几点是不是符合你对于这个问题的理解？
我确实不知道他在台上的时候担任职务的时候做过什么样的政策，但是他这一番见解你就反推出来，实际上美国政府是有非常聪明的一批人，现在在台上的也肯定有，只是说他未必是我们看到的总统啊、副总统啊，或者是部长，他可能是里面的一个研究人员啊，或者是一个局长啊，或者是一个部长助理，都是有可能的。他们非常聪明，如果他们没有这样聪明的话，他们就不会发现华为。只是说他们在工具使用的时候和目标的时候，确实不知道自己能不能成功，所以他们就采取了一些就是说名不正言不顺的一些事情，这种也达不到目的。你比如说伊朗这个案子，你就算是把孟晚舟给抓了，抓到美国来了、印度来了，把他判刑20年、30年或者500年，对吧？你觉得会阻止华为的研究吗？他根本达不到嘛。第二个是军事科技主要是2点，第一是这个战术武器。战术武器当然是有一个不断的提升的过程，但是这个过程是非常缓慢的，因为一个是军费有限军费相当一部分，大概只有1/3的时间来换这些装备，换这些装备的过程中间，它有一个不断的跟旧设备的一个磨合过程，这就造成一般性的常规武器它的更新换代不像大家想象的那么快，而且士兵军人他除了职业军人以外，很多这军官以外，很多军人的服役的时间都非常短，也就是说，他们操作武器的这个更新换代他跟这个军人之间的那种更新换代的时间不是很长，所以造成武器是倾向于保守的。那从战略武器来讲，我觉得中国的战略武器跟美国还差得太远，但是基本上可以形成一个军事平衡。所以一般来讲，现在追求这个芯片的这个限制跟这个中国的军力增长，大家应该明白不是那么大的一个关系真正的关系是什么？就是中国的量产化的能力，量产化的能力是不是这样？
的确如此但是现在呢，到芯片这个领域说到量产，其实也是华为需要解决的另外一个问题，就是毕竟你是没有，比如说极紫外光刻机这是 EUV是现在是这个阿斯麦最先进的这样的一个机器，所以呢，据 Trello 先生向我介绍呢，华为真正成功的秘诀是什么？就是在现有的设备的基础上，把现有设备能做的推向了极限，通过在软件和在其他技术工艺方面的创新那我们也说华为它的这个芯片设计部门叫做海思的，其实实力是非常强劲的。据这个 Trello 先生介绍其实对于华为来讲，他们在新款的 Mate 60手机中的这样的一个设计部门海思，实际上加入了一些非常独特的功能，比如说可以通过北斗的卫星系统发送信息，通过中国的这个天通系统打电话，这基本上已经不是5G 手机的功能了，而是5.5G 甚至是6G 手机。6G 手机很有可能就会把卫星通信作为主要的功能。另外呢，不管是华为也好，还是海思也好他们也采用了一些新的创新性的工程技术，对于他们现在手机的能耗和电池寿命都有了改善。所以就是说华为的这个海思是这个设计芯片的水平，其实早在几年之前就已经达到了5纳米甚至是3 纳米的水平，在新款的华为手机中啊，也有一些创新性的突破，这一些对于华为来说都不是问题。真正的问题是什么呢？就是你毕竟没有最好的光刻机，你毕竟生产一款产品，你的成本是高的。那么未来你走向市场的时候，你这个成本的问题如果解决不了，很有可能就导致你产品的竞争力是有限的，这个是一个问题。另外，华为的这一款手机还有一个什么问题呢？我们首先看啊，现在 Mate 60如果我们进行拆机的话，其中是有90%的半导体都已经来自于中国国内的生产商。那我们说是不是90%已经可以自主创新了可以这个自我供应了呢？但是问题是什么？其中一些最高级的一些内存元件仍然是来自于中国以外的供应商，比如韩国的 SK 海力士比如三星美光等等等等，这个也是一个问题。但这个问题呢，相对来讲没有光刻机这个问题这么严重，因为中国自己也有相当不错的NAND 闪存内存龙头企业，比如说这个长江存储比如这个 DRAM 的领军企业叫做 CXMT 等等等等。现在这些企业呢，也是在美国的实体清单上，也是被美国制裁了。但是目前来看呢，不管是长江存储也好，还是 CXMT 也好都取得了这个之前大家没有想到的突破。因此呢，根据 Triolo 先生的判断现在虽然是他们目前的技术比美光，比如说比行业领军水平是晚了4代或者叫晚了8年，但是短期之内追上应该来讲不是一个大问题。更重要的一个问题是什么？是整个生态的问题。
对，
像苹果呀、像三星这些智能手机商它往往都有一个属于自己的供应链的生态。根据我的设计来决定技术应该往哪个方向发展。同时，他们和台积电还有这些代工企业都有非常紧密的合作关系。新的设计、新的功能，台积电可以专门为你苹果手机开一条生产线。现在中国没有办法建立这样一个紧密的组装网络，而中国这才是需要解决的一个问题那么，华为现在不仅仅是有手机，也承担了叫做中国5G 发展突破卡脖子这样的一个关键路线。华为可能不得不在未来要开发越来越多的原创设计使用越来越多的我们叫做现有的技术来实现更高层次的制造工艺。而不管是中芯国际也好，还是上海微电子也好，还是我们叫做 Nora 或者是其他的芯片制造工具商也好，他们现在都要知道，自己所面临的不仅仅是满足国内的市场需求，也面临的是随时有可能面临美国更严格的出口管制，导致他们现在手里的工具也有可能面临短缺这样的一个问题。因此呢，不管是中国的半导体制造商，刚才我们提到的Nora 叫做北方华创SME 我们叫做上海微电子，还有 AMAC 等等等等，他们的工具现在都能够完成28纳米的生产，但是这离先进水平差的还相当之大。对于华为，对于中芯国际来说，出口管制在短期的确是给这一些行业部门和企业造成了相当大的麻烦。但是 Triolo 先生就跟我讲了一个观点，从整体上来讲，出口管制也导致了一个负面的效果，就是它提供了一个前所未有的市场激励，激励这一些企业可能要为一个之前不存在的市场提供新的需求。原来有台积电为华为来进行代工，那你中芯还
做什么呢？
没有，还做什么呢？只要是满足一般的低端的需求就可以了。现在台积电被排斥在中国市场之外了，恰恰是给了中国本土竞争者一个反超的机会。而对于中国来言，一旦你超越了14纳米、7纳米这样一个节点，因为这个出口管制你最严格已经管制到现在了，已经被我们叫做卡脖子被突破了。你未来不断在扩大出口管制的范围，已经很难对于中国本土的芯片产业构成真正的威胁了这是 Triolo 先生向我表达的一个观点。何明先生，你简要点评，然后我们再来说光刻机的问题。
OK， 我简要点评是2点第一点呢是这种出口管制的措施，它同时也是一种自残的措施，因为把原来有的生态的优势可能会受到伤害。比如说某些企业它往中国的出口它也没有了，那这个的比例对于很多企业来讲是非常之大的，它最终会产生什么样的蝴蝶效应我们不知道，也没人算这笔账，就像中美贸易战一样的，有人说是中国受伤害，有可能，那有人说美国受伤害也有可能，那谁做了一个量化的一个标准呢？没有。第二个是对中国来讲，毫无疑问是有一些困难，但它确实产生了一个 巨大的一个推动力。这种推动力呢，它是既有市场的前景在诱惑，又有国家力量在支撑，又有某一种人有时候的这种潜力就这么发挥出来了。所以在开始制裁的时候，我就在想一个问题：你卡中国有几个层次来卡？如果卡的这个层次最终是你达不到目的，反过来讲，那你这种的结果对于你原来的生态来讲的破坏力是非常强的，破坏力非常强。我们不知道中国人有没有这个运气，如果运气比较好的话，一般认为是几年时间，但是它不可能是个人力没有时间解的一个东西，对吧？所以如果运气比较好的话，几年之间一旦突破你的那个杠杆，你那个禁令就不会产生作用，然后反过来吃掉你原来的芯片生态的可能是非常之大的。
这也涉及到一个关键的公司，就是荷兰这一家阿斯麦公司啊。那么 Triolo 先生向我介绍，其实 EUV 就是阿斯麦最先进的这种制程工具，其实从来是没有到中国的，一直是对于中国进行禁运的。那么荷兰这一边呢，当时是同意了美国方面的要求，就是我们最先进的设备是不给中国的。但是在美国推出了升级版的出口禁令，对于 DUV 的相当一部分也限制出口给中国之后，实际上当时阿斯麦方面是非常生气的，认为是美国违反了之前的承诺，并且荷兰方面认为 DUV 这样一种工具已经有好多年了，已经不是先进技术了。现在你对于我们实施这样的限制，只能是影响我们自己的盈利，而对于阻挡中国是没有作用的。这样的一个细节我们之前也是不知道的啊。但是对于中国来说，最棘手的还是 EUV 工具所提供的能力。目前全世界也只有荷兰的阿斯麦能够生产这样的一个工具啊，光刻机、极紫外线光刻机。那么这个极紫外线光刻机造价庞大数十亿。那么工具也非常的复杂，你生产一台光刻机涉及到的供应商可能就有几千家，涉及到的复杂的立基技术可能有数十种，整个这个系统的集成是相当困难的。现在中国到底能不能够生产出和阿斯麦能够相媲美的 EUV 机器呢？我们还要打上一个问号。但是我们知道，以荷兰的技术实力生产出阿斯麦都是花了几十年的时间。而 Triolo 先生也向我介绍说华为实际上和现在中国其他的中科院下属的一些研究机构也是在紧急的研究极紫外光刻机整个这个大拼图的各个部分，其实在相当多的部分也取得了突破。但是他预计呢，就是说比较谨慎的判断，中国公司可能还需要4到5年的时间才可以开发出接近商业化的量产级的系统这呢是他大概给出的一个时间线。但是刚才正如您所说，4到5年对于华为来讲是痛苦的，对于中国来说，弯道超车也是必须要咬紧牙关我们叫做勒紧裤腰带紧急突破的这样的一段时间。但是4到5年不是无穷大4到5年也是一个可期的一个界限。如果中国的确是在4到5年，甚至是5到10年之内突破了这一道封锁，那么未来还有什么样的办法？这就要打上一个巨大的问号了。那么到底应该怎样评价美国的出口管制措施呢？ Triolo 先生在之前的一篇文章中给出了一个评价，叫做混乱而低效，以非预期的方式被使用，对于美国国家安全弊大于利，可以说是非常严重的批评那么他讲到了另外一点，就是除了推动中国公司在加速的创新周期中向前发展之外，这样的出口管制还有一个非常严重的负面后果，就是导致美国的先进技术在中国反而是被逐步淘汰出了市场。
对，
现在对于中国的出口管制，据 Triolo 先生之前的研究，已经导致了美国芯片工具制造商至少损失了几十亿美元的收入，并且对于未来的研发预算也是有负面的影响，未来的市场增长和未来的全球竞争力也是有负面的效果。现在由于中国公司在国内已经开始建立自己的替代网络，不管是英伟达还是 AMD 还是高通还是英特尔，这一些本来先进的美国半导体产品公司，可能会导致一个结果，就是他们会失去中国的市场份额，而且失去的份额随着中国本土竞争对手的赶上会越来越大。更严重的是，这一些企业也变得越来越脆弱，因为他们可能成为中国报复的目标。之前美光已经是开了先例，面临着数十亿美元收入和市场份额的损失。现在中国政府对于苹果，虽然不是一家直接的半导体公司，也是进行了相应的我们叫做市场化的一个压力。苹果公司也感到了非常明显的来自于中国的阻力。 因此啊，Trello 先生就得出了一个结论，说如果对于美国本土企业的伤害大于对于任何一家中国公司的伤害，对于美国本土竞争的伤害大于对于中国本身的阻碍伤害，甚至从长远而言还推动了中国本土竞争的发展，那么美国国家安全的收益到底是什么呢？因此他评价不仅低效而且混乱啊，给出了这样的一个评价。但是 Trello 先生也说，迄今为止，美国政府似乎没有任何人做了这样的一项研究，就是刚才何明先生所说的，对于出口管制的整体影响，你真正做一个成本和效益分析，看看到底是利大于弊还是弊大于利。而通过华为 Mate 手机的出现，似乎已经给了这样的一个算是大于号或者是小于号啊。所以呢，有关于 Trello 先生的这样的观点，他在跟我的这一段对话中有所介绍，在他之前写的文章以及他的作品中也有相当详细的介绍，我们特别推荐给大家。而在亚洲协会主持的这一场有关于中国和美国 AI 竞争辩论的这样的一场研讨会，我们已经做好了中文字幕，在今天节目之后会为大家播出。如果呢您想完整的看整个节目的话呢，在华尔街电视的华尔街智库栏目，我们也有专门的介绍。好，这个环节我们就介绍到这里。思想先驱报，谢谢您的收看。
Hello, welcome to this webinar brought to you by the Asia Society Policy Institute's Center for China Analysis. It is the third episode in this series where we delve into the intricate intersections of technology, geopolitics, and global affairs in the realm of AI. Today, we're navigating the complex landscape of military AI, US-China AI competition, Huawei's recent 5G breakthroughs, the effectiveness of US export controls, et cetera, et cetera. And we'll be talking about how to build a balanced framework in the world of AI regulation. I'm your host, Lizzie, and joining me are two amazing expert guests. First up, we have the distinguished Paul Shar. Paul Shar is the executive vice president and director of studies at CNAS. Paul Shar is the award-winning author of 4 Battlegrounds, Power in the Age of Artificial Intelligence. Paul, it's fantastic to have you here.
Thank you. Thanks for having me.
And joining us alongside Paul Shar is the equally distinguished Paul Trello. Paul Trello is a senior associate with the trustee chair in Chinese business and economics at the Center for Strategic and International Studies. Paul's views and writings are frequently quoted in international media outlets. Paul, thank you so much for being here with me.
Great to be here.
Now, as you might have noticed, we have two Pauls with us. So to keep things friendly and clear, we will refer to them as Paul S and Paul T throughout our discussion. So with that bit of housekeeping out of the way, let's jump right into our conversation. I should mention to our audience that you are free to use the webinar chat function to raise questions. We will leave 15 minutes at the very end of the webinar to address your questions. If your question is posed to a specific expert, please make that clear in the question. So for the first part of our discussion, we're going to turn to military AI and diplomacy. And here I'm going to turn to Paul S. Many of our audience will remember the recent diplomatic discussions between President Biden and President Xi concerning the responsible use of AI military applications. So Paul S., can you just give us some insights into how AI technologies are currently utilized in military applications and why their integration is considered a game changer in modern warfare?
Well, thanks so much, and very excited for the discussion today. There were certainly some tantalizing hints prior to the Biden-Xi meeting about a potential agreement between the U.S. and China on guardrails on military use of AI. We ended up not coming to fruition as part of the dialogue, but the U.S. and China are talking, which is really important because this is an urgent area that needs more attention. And certainly both the United States and China are working hard to adopt AI into their militaries, as are other countries and non-state groups around the world. AI technology is pretty widely available. And so we already see, for example, the use of image classifiers that are based on machine learning, that can use machine learning to identify images and objects in video feeds being used in drones in Ukraine. So you don't need to necessarily be one of the world's most advanced militaries or a leader in AI to use AI technology in the military. But there's some tremendous opportunities to do so, to process information faster, to make better and faster decisions. And there's a lot of value in the U.S. and China looking for ways to manage some of that competition, because there are risks in using AI systems that are unreliable and risking, potential accidents or escalation, and making sure that we don't see countries engage in a race to the bottom on safety, where they're deploying military AI systems before they're safe.
Fantastic. So, Paul, as moving on to China's military AI development, can you give us a concise overview of the current state of development, the potential challenges, as well as the implication for global security?
Yeah, so China is very keen to use AI to improve its military. We see them doing experiments like large drone swarm demonstrations, doing experiments using AI fighter pilots. Oftentimes, if the U.S. military does a major demonstration, we'll see China follow suit not very long after. And in Chinese writings, they talk about the importance of intelligentizing warfare, about using AI and other digital technologies, computer networks, big data, cloud computing to help process information faster. I think China, like other militaries, are trying to figure out, what do you do with these technologies to use them most effectively? And that's one of the things that stands out in the history of warfare, is that oftentimes new technologies proliferate pretty quickly, but what matters most is figuring out, how do you use this most effectively? And that pattern of innovation is probably going to be one of the decisive factors in which militaries are going to stay ahead.
Fantastic. And in the realm of military AI, are there channels, or what are the channels for the United States and China to establish international norms and agreements that both sides can commit to? We know military-to-military communication had been on hold for quite a while before the discussion between President Biden and President Xi.
Well, certainly direct bilateral communication is really key. So it's encouraging to see progress in that domain. And hopefully AI is an important area of conversation. But there are also international forums. There's obviously a tremendous amount of international discussions going on underway about AI more broadly. The Bletchley Park Declaration at the UK summit very recently that both the US and China signed. China had rolled out their own global AI governance initiative. But on AI military use in particular, there was the Responsible AI in the Military Summit, the REAIM Summit, just last year, and there's another one coming up. So that's another opportunity for both nations to then shape global norms and expectations, either independently or ideally together, about how AI should be used in the military.
Fantastic. Thank you so much, Paul S., for your insights. Shifting our focus a little bit, we're going to turn to the second part of our discussion, where we talk about the relative strength in AI between U.S. and China. There are recent media reports suggesting that China and the U.S. are actually nearing parity in AI development. Paul T., I'm going to turn to your expertise here. While the U.S. leads in fundamental AI technology and research, China is actually rapidly implementing them in practical applications. So what factors drive this divergence in the style of U.S. development, and what are the potential implications?
Great question, Lizzie. And I'm not sure I would couch it quite like that. I think, companies in both countries have been deploying AI for a long time. In various types of applications. So I think it's important to just step back quickly and define what we mean by AI here. In 2017, I wrote an article with Kai-Fu Lee where we tried to look at China and the US and where they were in AI development. And we broke it down into several different categories. Internet sort of based AI, things like recommendation algorithms, business and enterprise focused AI, things like logistics and business operations. Perception AI, which is things like facial recognition, object recognition, and then autonomous AI, which is things like AI being used as part of autonomous vehicle systems, ADAS systems, for example. So in all those areas, we looked at which country was leading, which companies were leading, and China, of course, was very early on, companies like Alibaba and Tencent were using AI algorithms in things like e-commerce transactions. And also in things like logistics. So Chinese companies were very, very early users of AI algorithms in very sort of, application-related processes. Perception AI, too. Chinese companies were leaders. Chinese researchers had done a lot of research and participated in national conferences on perception AI, things like natural language processing. And then on autonomous, we gave the U.S. a little bit of a lead here. So we tried to break it, get under the hood and get away from just, AI. I think if you look at sort of across the AI stack, you look at things like data, access to data, and then the sort of hardware area, that's a tricky one. Kai-Fu has said, talked about China leading in data. That's a complicated issue. Yes, they have a lot of data sets that may be unique. Each of the companies, for example, developing AI in China has access to big data sets. Baidu has 20 years of search history. Tencent has a lot of transactional data. Alibaba has a lot of e-commerce and logistics data. But I think the interesting thing is, as we get to the current situation, which is where the big focus is on generative AI and large language models, we're sort of in a little bit of a different world. And there, yes, arguably U.S. companies like OpenAI, Inflection, a lot of the sort of foundational leaders are leading in the sense of innovating and designing new approaches to generative AI. Transformers, for example, came out of the U.S. research community here. So in that sense, the U.S. research is leading, but Chinese companies are quickly coming up to speed on these areas in generative AI, both in terms of deployment of applications and in terms of sort of improving on existing models and developing their own models. There's something like 238 large language models now under development in China, which is a large number. And certainly companies like Baidu with ErnieBot that they just put out, it compares favorably, for example, in terms of performance with ChatGPT 3.5 and even ChatGPT 4. So the generative AI is sort of a new area where it comes out of the natural language processing and image processing, but it's still, the use cases and the sort of applications are still under development. And so trying to assess who's leading in that is a bit of a challenge. On the hardware side, though, I think obviously the U.S. and U.S. companies in terms of developing advanced GPUs are far ahead of the game, and we'll talk more about that when we get to the export control piece of it and why that's such an obsession of the U.S. government in terms of controlling Chinese company access to GPUs. But clearly, Chinese companies have been trying to catch up in the hardware development space, but that's really challenging. NVIDIA and AMD and Intel, for example, have big leads there. And particularly in things like software development environments around AI, which is a critical part of the AI stack. Chinese companies are lagging, and most developers use PyTorch and TensorFlow that come out of Facebook and Google, for example. And so it depends on what you're talking about, what part of the AI stack, and how quickly the Chinese companies have been able to sort of come up the learning curve. So when you talk about who's leading in AI, you have to be very careful, I think, and quickly get under the hood and look at some of the individual applications and processes. But definitely the general consensus in 2017, when I wrote that first paper, is that U.S. companies tend to be leaders in sort of basic research and innovation in the space. But I think that's a general comment, but I think that's changing fast. Chinese researchers are very good in these areas, and then of course in terms of application using AI across the board, Chinese companies have been very out in front on all this. And generative AI finally is the area where it's hard to say who's leading, and that's just something that will unfold over the next couple of years in terms of actual applications.
Fantastic. And we'll be talking about sort of China's strategy to catch up, so to speak, on hardware and other fronts. But before that, Paul T, can you also shed light on some of the key industrial or commercial applications of AI technology that China is currently prioritizing? I mean, I've heard a lot of talking about AI diagnosis. I've heard AI-powered, sort of automatic, driving, et cetera, et cetera. So what are those key areas of commercial applications that you can see in China, and where investors are now focusing in terms of China's AI landscape?
Yeah, great question. And, again, going back a little bit, this has been an evolving sort of situation in China. Or the first wave of AI applications did tend to be in things like e-commerce, and in the facial recognition area. Of course, public security in China was interested in robust facial recognition systems, and so a lot of investment and money went into those companies. But I think now we're sort of in a different wave here, where we're looking at companies actually need to make money now, and also to figure out applications that will drive revenue. So yes, one of the areas I would say is medical diagnosis. And that's been, again, sort of in around for a long time, but Chinese companies have been particularly good in this regard. So just this week, for example, there was an interesting paper released in Archive that talked about an AI application for detecting pancreatic cancer, and it's interesting sort of data point here. It was written by a whole range of authors from including from Chinese sort of medical researchers, and Alibaba's Damo Academy was one of the lead authors. But there were participants from Harvard, Johns Hopkins, and a university in Prague. So that shows that, particularly in that kind of application, medical diagnosis, it's a very global and cooperative field where AI researchers in the US and China and other countries are all collaborating. There's other really good companies like Infravision, which is another company, Chinese company, started by two Chinese grad students who went to university in the U.S. They then went back to China and trained their AI algorithm for detecting cancer in China, working closely with hospitals. And then they're deploying that algorithm in the U.S., hiring engineers in the U.S., and they have a presence in Europe, in the U.K., and in the rest of the Asia Pacific. So in that case, it's a good example of a Chinese AI company that is able to go global because there are maybe less sensitivities around things like medical diagnosis of tumors and other things, right? So that there's some good examples of Chinese companies in that. The other area is ADAS systems, as I mentioned earlier. So a lot of Chinese companies, of course, are really advanced in deploying AI applications in autonomous vehicles. So if you look at a company like Pony AI, for example, they have a level 4 capability. I'd ridden in one of their vehicles in Beijing with no driver in the front seat, navigating a complicated suburb of Beijing, and it was quite good. It was way better than the Tesla that I drive, which is only level 2 plus. But it really felt like the car was in control the whole time. So Chinese companies, including Huawei and of course Pony and WeRide, a bunch of other ones, are really doing quite advanced work in AI algorithms applied to autonomous driving. And then finally, with generative AI, you see companies like Huawei doing things like port automation. So if you go to this demonstration port in Tianjin, there's no workers there. Everything is being done remotely by a couple of people. And it's all automated, and it uses a combination of AI and other techniques. 5G is of course, an important part of that. And then there are applications in mining. So Huawei is using its Pangu large language model, for example, in as part of automation of mining operations. There's a big mining operation in Shandong that's all automated using a combination of, again, generative AI and 5G. So there's, those are the kinds of applications that are a huge focus in China right now.
Fantastic. Thank you so much. Since you already mentioned Huawei, so let's turn to Huawei next. And we'll be talking more generally about China's quest for domestic AI hardware and chips. So turning our attention to Huawei, we know the company has faced challenges amid U.S. sanctions, et cetera, et cetera. And despite this, they've managed to re-enter the 5G phone market. I'd really love to hear from both of you, starting with Paul S. So Paul S., can you sort of detail the strategies employed by Huawei and what are the lessons to be learned from Huawei's breakthrough?
Well, they're certainly going to make do with the technology that they have on hand and see as far as they can take that in terms of building more advanced chips. I think what remains to be seen is how far they're going to be able to take that. And I think we'll see they've certainly been able to develop some more capable chips. I think the biggest question is going to be, can they scale that in a way that's cost effective? And one of the big unknowns here is U.S. export controls is then pushing Chinese companies to maybe use the technology in novel ways or simply invest in new types of technology for leading edge nodes, or to circumvent those means of production and find potentially new different kinds of breakthroughs. In the short term, they're going to have significant challenges going forward. It's clear that the export controls are going to be able to slow down some development and put some roadblocks in their way. I think in the long term, there's some very open questions, and it's going to be very challenging for the U.S. controls to actually hold back Chinese chip development over time.
Fantastic. So, Paul T, please also chime in here. How do you assess Huawei's current state of development in terms of its chip technology? What are the lessons we should learn from Huawei's surprising breakthrough?
Well, you have to put the breakthrough in some context. I got a hold of a Mate 60 in Shanghai a couple of weeks ago. It's a very impressive device. So again, it's important to note that there are the two real big strands coming together here. One is the export controls on Huawei itself, and the extension of extraterritorial export controls on Huawei that prevents it from using TSMC, for example, to manufacture those advanced chips. And the other strand of export controls, which is newer, coming from last October 7th, is our controls on SMIC, the domestic foundry that actually manufactured this chip, probably at the 7-nanometer node, although both companies are being pretty mum about the origin of this chip. But basically what happened was HiSilicon, which is the chip design arm of Huawei, was designing at a very advanced level before the U.S. put controls on Huawei in 2020. And so HiSilicon was designing at 5 and 3 nanometers. And so what Huawei's been able to do is turn that HiSilicon design around and use it with SMIC's capacity to do some layers at 7 nanometers using their existing tools. Now, those tools that SMIC used, they've had since 2019. The actual techniques for manufacturing advanced semiconductors at that level using those tools that SMIC has are well known in the industry. So even before the October 7th controls, SMIC and Huawei had everything they needed to actually manufacture that chip. Now, the challenge is manufacturing that chip at commercial yields and scale. So there's still a lot of questions about, as Paul noted, about whether SMIC can ramp up and manufacture the tens of millions of systems on a chip that you need if you're going to be sort of competitive in the smartphone business. This is a very different business model, for example, than say 5G base stations. And so there's still some question about whether how quickly and rapidly SMIC can ramp up to produce the numbers of systems on a chip that Huawei will need, and then where they go. What's the roadmap going forward? There's still a lot of concerns about that. Currently, the thinking is you can take the equipment that SMIC already has, the advanced DUV lithography equipment, for example, probably can go to some level of like 5 nanometers. It's capable of doing that, but it's just really challenging to do that and get the yields you need to sort of produce the again sort of tens of millions of chips. Before the export controls, for example, Huawei was producing 250 million chips, the Kirin 9000 series at TSMC. So that's the kind of scale you need to be able to sort of produce generation after generation of chips. Now, one thing we should just quickly mention too is that the U.S. export controls, one effect of them has been to force Chinese tool makers to get better, to sort of be more innovative. And so what we've seen, for example, is the sort of vertical integration of Chinese chip tool makers working very, very closely with the foundries in China, like SMIC and Huahong, which is another key player. So when you try to determine how effective the export controls are, of course, they're effective in cutting off some access to technology, but Chinese companies have been pretty effective in working around that, as we see from the Mate 60. And also Huawei used a lot of very interesting engineering techniques to try to mitigate some of the deficiencies of having to use the less advanced node. So, for example, things like power consumption, they managed to do some novel things to improve performance there. And they've included in the Mate 60 some 6G, 5.5 or 6G capabilities like satellite communications, satellite messaging, and satellite phone calls. So they're really pushing the envelope in terms of engineering, using their existing tools and using the existing capabilities that Chinese companies have. So it's a pretty impressive feat, regardless of what you think of the export controls.
Thank you so much. So, we talk about Huawei and SMIC, but what's sort of the general status of China's domestic chip development, especially compared with global leaders? I want to hear sort of a evaluation from both of you. And, besides Huawei and SMIC, as we mentioned, who are the prominent players in this place that we should be, on the watch out for? Please, starting with Paul S.
Sure. So I think, China's indigenous chip making capacity has lagged behind the industry for a very long time. It's an area that they've struggled to develop despite a tremendous amount of government investment in this space. Now, of course, the export controls change that dramatically in two key ways. One is that the U.S. controls, along with Japan and the Netherlands, on chip-making equipment, make it even harder for foundries like SMIC to be making chips because they're cutting off their access to the most advanced technology, things like extreme ultraviolet lithography and associated other tools and equipment. However, what the U.S. export controls also do is create enormous market incentives for Chinese chip makers and equipment providers to then find ways to innovate, because the U.S. controls, the extraterritorial controls on the chips themselves, now create this huge market for advanced chips inside China, the kind of chips that Paul was talking about that Huawei was making. Now they're denied access to from TSMC, from their advanced nodes. And so there's now big advantages inside China for finding ways to maybe be more creative, using deep ultraviolet lithography, seeing how far can you go there. I think very much an open question. But we've also seen that not just in China, but globally, there's been this huge explosion of companies in the design space. So while there's been a concentration of companies on the foundry space, at each node, there's fewer and fewer companies, making the most advanced chips, manufacturing them. In the design space, there's lots of companies designing chips, and a lot of Chinese companies are doing innovative things in the design space, and that's a room for them to continue to grow. Kind of to some extent bottlenecked within the nodes that they're going to have access to on the manufacturing side, but continue to innovate and design. And so I think, we're going to see how far China can push that, but there's big incentives for them to do so to try to meet that market.
Thank you so much. And turning to Paul T., how would you assess China's current state of development in terms of?
That's a great question, Lizzie. And I've actually got a paper in draft that's looking at sort of where China is overall in the semiconductor industry. So just a quick highlight. I agree with Paul on the design side. Chinese companies are very advanced. HiSilicon was designing chips, that were comparable to Qualcomm and other leading companies in the sort of smartphone space. And you've got other companies like Unisoc and Xiaomi. A lot of the phone companies have tried to get into design. It's a really tricky thing to get into, though, because it's a big commitment financially if you're going to really get into advanced semiconductor design. But you also have companies in the GPU space like BREN and More Threads that were also added to the entity list around October 17th. But the big players in China like Alibaba and ByteDance are also designing their own chips. And so, there's a lot of players in that space. Horizon Robotics, for example, is another key player designing edge AI semiconductors and is doing quite well. The problem, as Paul notes, is fabbing this stuff. And how do you fab this stuff when in some cases you're cut off from doing advanced designs at TSMC? If you're a Chinese company that's on the FDPR entity list, for example, which will prevent you from using TSMC. So a lot of these companies are on those lists. So in China, you have SMIC, and you have four really major fabs. You have SMIC, Huahong, and then for memory, you have Yangtze Memory, YMTC, and CXMT. And each one of those is under some sort of U.S. sanction and is trying to figure out a way around this by working with the tool makers. CXMT today just announced a breakthrough in DRAM, for example. But again, if you look at that, it's basically 2020 technology or 2018, 2019 technology. So a lot of the efforts in the fab space are Chinese companies catching up to basically 2 or 3 or 4 years ago of where the Western leaders were. So the challenge going forward is how do they keep moving up the value chain? So as I noted, the Chinese tool makers, and this is companies like Naura and AMEC and SMEE. These are companies that are competing with Western tool makers like Applied Materials, Lam, and KLA Tencor for metrology. And so all those companies in China now have, as Paul noted, have this incentive to get better, move up the supply chain, but also work much more closely with the foundries, because that's really how Western tool makers work. All the U.S. tool makers, for example, work very closely with TSMC, and that's how you get better. You work with the design companies designing advanced designs. Then the tool makers have to make better tools, and the companies that are fabbing those chips have to figure out processes that can use those tools and be used for manufacturing advanced designs. So all that is happening within China, but it's a big challenge because as Paul noted, the export controls mean that those foundries can't get access to EUV lithography, for example, which is what many of the other foundries are using, Intel, TSMC, and Samsung. And so they have to figure out a way around that. Now, there's lots of other things that the Chinese government and the Chinese companies are trying to do to figure out alternative approaches to things like advanced lithography. Because really, in this space, these technologies, it's not like that U.S. companies or Japanese or Netherlands companies have technology that's locked in a box, and then if you prevent China from getting it, China can't do it. These are applied science. This is applied science, and so there's many different ways to do these things. For example, with the tool makers, and so Chinese companies, and with help from the Chinese government, are trying to figure out ways to do things differently and do things better, and trying to get to some point where they can get back in the game of manufacturing advanced semiconductors. Probably next year they'll have a 28 nanometer line that's all domestic tools, probably still with ASML lithography as part of that, and then they'll move to 14 nanometers and have a fully qualified domestic production line without any largely free of Western tools, except for probably in lithography. So there's a lot of efforts underway in China to do that, and the Chinese government has revamped its whole approach to semiconductor industry policy, and is going to be driving some really innovative efforts in that sector. For example, to share government R&D with a select group of Chinese commercial companies to try to push and get around and sort of advance despite some of the U.S. export controls. So this process is going to play out over the next 2 to 3 years as Chinese companies like SMIC extend the capabilities of their existing tools and try to figure out where to go from there.
Fantastic. And in the next section, we're going to turn to policy. We're going to discuss sort of the effectiveness of the United States policy of export controls and sanctions, and the Chinese policy of semiconductor industrial policy is big fun, so to speak, as Paul just mentioned. So I'm going to turn to Paul S. first. As you know, the Biden administration recently expanded its set of restrictions on exports of advanced computing chips to China. Do you see these new sets of rules as likely to be more effective in achieving the administration's intended goals?
Well, to some extent, we know that they are just because they capture now a wider set of chips. And one of the things that we've seen is when the export controls first came out last year, NVIDIA, of course, adjusted their chip designs to fall under the threshold. U.S. now moving that sort of yardstick in terms of what's permitted. And it's clear that the U.S. government is going to continue to be adaptive to what we're seeing U.S. companies do, as well as Chinese companies and others, to try to cut off ways of China getting access to either chips or chip-making equipment. But it's going to be a moving target. And whether it's ultimately effective in restraining Chinese chip development and AI development is, I think, really challenging, not the least of which because when it comes to AI, there's actually lots of ways to get access to the computing hardware that you need. Chips themselves are one way to do that. But another way is through cloud computing providers. And the export controls, go after that as well, expanding the scope, looking at data centers of Chinese companies outside of China. The executive order that the White House recently released begins to make moves on know your customer requirements for U.S. cloud providers. And so those are some steps the U.S. is trying to take that I think are going to be needed ultimately if the U.S. is going to have to try to find ways to be restricting Chinese companies' access to cloud compute. Actually, cloud is a better approach for the U.S. to take that can be a little more fine-grained in terms of its approach. The U.S. has talked about concern about Chinese military use, human rights abuses inside China, and certainly with the recent export controls, a lot of concern about what the executive order talks about as dual-use foundation models, so the most capable advanced AI models. And if you can control through the cloud, that actually can allow more fine-grained controls, which could undercut some of these market incentives that exist that we've been talking about that are driving Chinese chip development internally. So there could be a better approach over time. And then the last component that really remains completely unaddressed in all of this is open source AI models, which is to say that right now in the current setup, you have large US companies training cutting edge AI models and then releasing them open source, which entirely circumvents US export controls. So even if the US is successful in restricting China's access to chips themselves, that doesn't matter if Chinese labs can go download an open source model and then fine tune it at very, very low cost. You don't necessarily need the most advanced chips to do that. And so I think we're going to continue to see the US government be responsive to changes in the marketplace and in the technology, but it is a moving target, and there's still a lot of gaps in US export controls.
Fantastic. And Paul T, please, your take on the effectiveness of the new set of export controls.
Yeah, great question, and agree with Paul's take on all this. I mean, I think the challenge here is, these controls were not really designed for some of the current purpose they're being put. I think we have to remember this. They were designed in an era of weapons of mass destruction, where you had sort of small companies that were producing a key widget that could be used, or key material that could be used in a nuclear weapon. They were not designed to maintain U.S. technology dominance or to prevent China from getting AI capability or high performance computing capability, or deal with human rights issues, right? So I think that's sort of the backdrop of all this. And so we see this challenge in sort of trying to draw lines around the technology that we saw with October 7th on the GPUs. NVIDIA right away came out with the CPU, GPUs that were just below the threshold, and we saw this again on October 17th. So that just highlights the challenge of using things like export controls for these purposes that they weren't designed to do. And also, you're trying to, in this age, you're trying to get on the tool making side, for example, it's a global issue. So you have companies in other countries that would need to align with the U.S. if you're going to have effective controls. And there, we at one point had the Wassenaar Agreement, which was a multilateral group, but Russia is part of that, so that's not sort of dysfunctional. And so you've had to have these other sort of workarounds with the U.S. and Japan and the Netherlands agreed to some collaboration on controls around semiconductor manufacturing equipment, but not on all controls. And so there's still a lot of disagreement. And the Dutch government and Japanese government, and the companies in those countries don't like the some of the controls because China remains a huge market for them, and they're reluctant to fully align. So the challenge of the export controls sort of is it's a tool that sort of arguably needs to be revamped. So it's not surprising that there are ways that companies find ways around this, both on the U.S. side and on the China side. And then the other piece of it that I think is important is, what's the ultimate goal here? Is the goal to really prevent China from getting advanced computing capability? This was called out last year, for example, in what I've called the Sullivan Doctrine, where National Security Advisor Jake Sullivan talked about advanced compute and biotech and green tech as these force multipliers that are of key national security concern to the U.S. But advanced compute is a huge area, right? It includes semiconductor manufacturing equipment, AI, quantum computing, and high-performance computing. And China already, for example, has a very robust high-performance computing capacity. AI comes into play where there's some convergence of AI and high-performance computing with the use of advanced GPUs, for example, to do acceleration for certain kinds of workloads in the HPC space. And that's one of the arguments for controlling these technologies, is that China could use high-performance computing, it already does, to model weapon systems like hypersonic glide vehicles and missiles. And so that's an argument that the administration continually makes, that it's trying to control a small amount of technology that has military end use. The problem is that those GPUs the vast majority of them are used for non-military applications in China. They're used for drug discovery or as we talked about, cancer detection or materials development. So the vast majority are not used for military end use. And so the administration is controlling, in a sense, this sort of very, very dual use technology in ways that have a major impact on China. So, for example, already after the October 17th controls, Alibaba and Tencent said this would have a big impact on their cloud services, right? These are companies that don't provide anything to the military, arguably, or very little to the military. And they're commercial companies. They're e-commerce companies and social media and gaming companies. But the impact of those October 7th controls is hitting them because they can't have a reliable long-term source of GPUs to offer services in the cloud or to design generative AI models. Most companies in China have stockpiled about 2 years worth of those advanced GPUs, and it'll probably be okay for 2 years. But then after that, the question becomes, what happens? What other workarounds are they going to be able to find to continue to have access to reliable, advanced hardware? So again, the question of sort of how effective the controls are, it depends on, what one believes is the end goal of this, and whether this is a realistic to believe that the U.S. government can control China's ability to develop high performance computing and advanced computing and AI by controlling so-called choke point technologies like GPUs. And I think the jury is still out on that because, the technology is very complicated and changes rapidly. And these controls there are ways to circumvent these controls. But the longer term issue is AI, whether AI and how important that will be for national security and things like cybersecurity, and, enabling malicious actors to develop bioweapons using generative AI models. And that's the fear, I think, in the U.S. government, in the EO that Paul mentioned, on AI EO, there was a big focus on national security related issues around AI. And then the sort of general fear that over the long term, artificial general intelligence, whoever gets there first, will have a big advantage, both from a sort of national security and economic security point of view. But that's a far-flung sort of concern to be implementing controls now. And again, that highlights my initial point that these controls were not designed to prevent, the future development of artificial general intelligence by some malicious actor or by a country. So it's a very challenging prospect. And in the short term, the big losers are arguably, in this case, U.S. companies, whether it's the tool makers on the manufacturing side or the tech companies like NVIDIA, Intel, Qualcomm on the sort of the chip sales side. So it's a challenging issue to determine, are these effective and sort of who's winning.
I see. So, Paul, since you mentioned, I just wanted to talk a little bit about the misalignment of incentives, so to speak, here. Are other countries on board, or to what extent are other countries like the Netherlands and Japan and Korea on board with the United States set of export controls and sanctions? And how are industry leaders, to whom China is still a vast market, navigating this new regulatory landscape? How are they thinking about those export control measures? I'm going to start with Paul S., please.
Sure. So on the export controls on the manufacturing equipment, the U.S. has been dragging Japan and Netherlands along reluctantly, as Paul mentioned. There are some disagreements between the allies on what specific kinds of where to draw the line on some of these controls, and there's a lot of money at stake for these companies in, frankly, all three of the countries, including U.S. companies. Well, it's a little bit different with U.S. companies, where U.S. companies, of course, have, depending on the company, many of them have huge incentives to be supplying technology, whether it's chip making tools to get that they can with export controls, or chips themselves, as we see the case of NVIDIA, to the Chinese market. And U.S. companies are going to find ways to continue to supply to the Chinese market to the extent that they can, that it's permissible by the U.S. government. And now I think, the latest development on the chip export controls, for example, where when they first came out, there's a certain threshold by the U.S. government. NVIDIA redesigned their chips, released ones just under the threshold. Now we've seen the U.S. government move that even further. I just want to point out, it's not necessarily a bad thing if U.S. companies are saying, okay, we're going to go ahead and ship whatever the technology is just below the threshold that the U.S. government sets. If you set the threshold in the right place, that's fine. What that may highlight is if then the U.S. looks at that and the government says, well, actually, we're not happy about that. Maybe we set the threshold in the wrong place. Mm-hmm. And we need to see some adjustments there. But ultimately, like the big picture here, and Paul was talking about sort of this wide, expansive set of these export controls, is in the U.S. government's interest for these controls to be as narrowly scoped as possible for whatever goal they're trying to accomplish. And it's been a little bit uncertain exactly what is the goal the U.S. government has here. Jake Sullivan's given a number of speeches talking about, and last fall, when the export controls first rolled out, talking about the shifting the U.S. goal to keep China as far behind as possible in these technologies. But specifically with regard to the chips, the U.S. government's talked about Okay, these very narrow military-specific applications, WMD, hypersonic missiles. Okay, is that what they're going after? Is it to create some distance between Chinese labs and U.S. labs on the most cutting-edge models, which are now we're seeing very much dual use, and they have a lot of commercial applications, but also potentially applications in enabling the development of chemical and biological weapons, in cyber tools, in basic scientific discovery. I think there's a lot of unknowns there, but we can already start to see with GPT-4 some kind of hints at some of those capabilities in potentially future models that may not be further down too far down the road. So is that the goal? Or is it just across the board to try to hold China back? And right now, the export controls are so broad that they're affecting things like commercial cloud applications that are not only not militarily relevant, it's just hard to see the strategic significance to the U.S., even as sort of like a basic foundational science and technology advantage here. And so, the extent that the U.S. can find ways to more narrowly scope these controls, obviously we want them to be multilateral with allies, but to make them as targeted as possible, it's going to be in U.S. interest in the long run to make sure they do that.
Fantastic. Thank you so much. Paul T, please also weigh in here.
Yeah, just real quickly on Japan and the Netherlands. This is a complicated issue because neither of those countries has, for example, the type of end-use controls or domestic person controls that were included in the U.S. package on October 7th. And so that has complicated the issue of getting some level of collaboration. And companies in those countries like ASML, for example, in the Netherlands are really, they're a huge company. They're sort of the Google and the Intel all rolled into one of the Netherlands. And so the Dutch government has not been eager, for example, to go along with all the U.S. controls. On October 17th, for example, the U.S. added a technology parameter called dedicated chuck overlay, which is a DCO, which is a really complicated term, but it refers to how you get accuracy, for example, in DUV lithography systems. And that meant that the Dutch now have to control much older gear, so gear that's more than 10 years old, that could be used by some end user in China, for example, to try to get around some of the limitations on the end use controls that the U.S. has imposed. And the ASML, of course, is livid about this because they don't. This is not cutting edge technology in their view, and they have a lot of equipment in China that falls under these categories. And so both the Japanese government and the Dutch government, for example, are really not eager to align fully on these controls because their companies are going to be the ones impacted. In the case of Japan, TEL and Canon and Nikon, for example, are all producing equipment, and China is a huge market. Those countries are also concerned about Chinese retaliation, which we haven't talked about. And there's a growing concern that China will retaliate against some of these controls. So this week, for example, I think tomorrow or Friday, Chinese controls around graphite will go into effect. And the graphite controls they put into effect were a direct response to the October 17th controls. So China has not yet pulled the trigger, for example, on some of these restrictions they put in place on gallium and germanium last summer in response to U.S. export controls, and in October around graphite. But that's the concern that companies in countries that are aligning with the U.S., for example, on some of these export controls could be impacted by Chinese retaliation. So as Paul rightly knows, I think the argument in the Netherlands and Japan is that these controls should be very, very narrow. And before October 7th, there was some understanding about how narrow the controls should be amongst some of those allies. And then when the October 7th controls were released, they turned out to have been expanded considerably, for example, around some of the end-use controls that surprised U.S. allies. And so that the last year has been, in part, very detailed negotiation around trying to get and arm-twisting allies to align with those more expanded controls. And so getting back to Paul's other great points, Jake Sullivan has talked about a small yard, high fence. But if you look at the U.S. policy and other aspects of what Jake Sullivan has said, for example, around advanced compute, the yard is pretty big, and the fence, is sort of growing, but because of these technologies have global supply chains, the yard is necessarily large because you do have other countries and companies involved in this. And so that's been part of the challenge is is that the discussion has been around that this is a narrow approach, but in reality, it's been a much broader approach, and that has impacted a lot of companies in the supply chain and the semiconductor supply chain, and arguably a lot of U.S. technology leaders whose argument is that access to the China market is important for them to continue to do R&D and maintain their leadership position in these advanced technologies, and that's a national security issue. That argument hasn't gotten a lot of traction in Washington, but that's what how the industry views the controls, sort of verging away from a very, very narrow focus on a smaller set of advanced technologies.
Fantastic. Let's turn to the other side of the coin, so to speak. How would you assess the likely success versus the failure of China's industrial policy when it comes to semiconductor, big fund version 2, etc.? Starting with Paul S., please.
Well, certainly we've seen that China's been willing to invest tremendous amounts of money in not just chips, but other areas in terms of industrial policy with mixed success. And in some areas, they've had significant progress. Chip making has been a long struggle. I think, big picture, a lot of these efforts, they're very inefficient. They're very wasteful, but the government has been willing to spend tremendous amounts of money, and they've been able to make progress in a number of significant areas. Now, again, one of the biggest challenges here with chips is it's not just money in the past. Money has not been enough to get there. But what's different now is that there are these market incentives for Chinese tool makers, chip makers to be meeting this demand. And, that creates these feedback loops where you've now got, as Paul was talking about earlier in our session here, tool makers working closely with the chip makers, getting that kind of feedback and, getting products out into the marketplace, engaging with, users, whether it's other companies or commercial users, and getting that feedback on performance is going to help to level up quickly. And certainly that's a very different kind of role that the government plays than we see here in the United States. We've seen some movement, of course, recently in the U.S. in terms of the U.S. government taking a bigger role in science technology innovation with the CHIPS Act and significant amount of funding towards U.S. chip making here, R&D, and more advanced foundries here in the U.S. But in general, still the U.S. government's been just much more reluctant to be engaged. For better or worse, obviously, government spending can be much more inefficient than the private market. But there are lots of ways where government investment in basic R&D might be doing things that private companies aren't willing to do on their own.
Yes, turning to Paul T.
Yeah, I think, and again, I'm writing a fairly detailed paper on this, on China's sort of reaction to all this. But I think there's a couple of things just to highlight that are new. So there's going to be more of a top-down leadership in China when it comes to semiconductors. There's a new leading small group at the very top that's going to be overseeing this. Basically, the Chinese have gone from allowing sort of the scientific community to drive things. This is back in the 863 program days, where there was a much heavier government role. Then, with the setup of the National IC Investment Fund in 2014, the idea was to give market forces, more play. And the view now in China is that failed. And so there's a view now that China needs to figure out another approach to this. So potentially, for example, they may have a large state-owned enterprise that play a more prominent role in helping to drive the overall sector, because that's worked, for example, in the aerospace and other sectors where China has been successful in advancing the technology, and particularly domestically. And so I think that's gonna be one thing. Then there's also going to be, as I noted earlier, more sharing of R&D with key private sector companies. So among those private sector companies are Huawei, SMIC, and Naura, that tool maker I mentioned. And that was announced earlier this year. And so there's going to be a lot more trying to leverage government R&D in these key choke point technologies, arguably, things like lithography, to try to help advance the sector. And then I think the new round of the National IC Fund was just funded recently, and it's going to focus on tool makers, because they now belatedly realize that a lot of the focus was on design and manufacturing, but it turns out that the tool making area has been the big Achilles heel, given, of course, the U.S. controls in place. And then I think there's also a lot of sort of R&D going on under the radar. Huawei, for example, has a tremendous amount of experience in all this manufacturing, all these manufacturing technologies, and I think they're working very closely with the tool makers and with companies like SMIC, obviously, on a whole range of new approaches. Huawei probably realizes it should have been more like Samsung, and is probably now pursuing that kind of a strategy where Samsung has its own foundry business, so they do all the commercial electronics, but they have a massive foundry business that manufactures most of their products. And I think Huawei probably regrets not pursuing that strategy earlier. And then I think the one other goal is to keep access to Chinese companies for critical things like materials and things like substrates and process gases, which haven't so far been the subject of export controls. So, for example, Japan and Taiwan and other places are critical sources of substrates and some of the things you actually need to do advanced manufacturing. And China's going to continue to try to keep access to those. And then I think finally that the Chinese Chinese companies are looking to poach more engineers and knowledge from companies in Japan and Korea and Taiwan, which is where a lot of that knowledge goes. Because really, at the end of the day, this industry is about knowledge and knowledge transfer, and so you need the people who know what they're doing to actually do this. The guy, for example, at SMIC who helped them move to the 7 nanometer process, was previously an executive at TSMC and Samsung, yes. And so those are the kind of people you need if China's going to make progress in these areas. But I think you have a whole of government effort here and a whole of industry effort to try to figure out the way forward here, and that's going to unfold over the next couple of years.
With that brilliant insight from both of you, we conclude the first part of our discussion